little mini lesson about using the area model to help with distributive property. And so I have here some square graph paper that we'll use. And I know that when you first started multiplication, if you wanted to model like 3 times 4, you could make 3 rows and 4 columns. And then you would say, okay, how many squares is that? All right, because that's what area really means, is how many squares are inside of something. And so then you could count them. You could say, oh, look, there's 12. There's 12 squares. Okay. So I'm going to extend that a little bit and make this a little bit harder, because it's really nice to use the area model when you have more difficult problems. So let's suppose instead of 3 times 4, which we already know is 12, what if we had like 5 times 16? A student asked me that question yesterday. What's 5 times 16? And so maybe you are unsure about that one. That's not a fact that you have memorized. So I could draw that. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so here's my picture. Now, of course, I could still count that, but that sounds really awful, right? Nobody wants to count that many boxes, but I could divide 16 up. I could divide 16 up into 8 and 8, right? Okay, and then I could say, okay, well, this area in here is 5 times 8, so that area is 40. And then I know that this distance is also 5, so this area is 40, and I could add them up. And so I know that 5 times 16 is 80. Okay, now I could divide it up differently. Sometimes maybe you want, instead of to divide it up with 8 and 8, what if you divided it up with 10 and 6? Okay, this is 5 times 10, which is 50, and then 5 times 6, which is 30, and then you could add those two parts together, and it's 80. Okay, so still 80, even though I divided it in a different spot. So what if I did a different one? What if I did, instead of 10 and 6, what if I did 4 and 12? Okay, well, 5 times 4 is 20. 5 times 12 is 60. And then I could add those together and get 80. So I'm using the model of multiplication that you've learned from the beginning, but I'm dividing it up in different ways. Okay? What I like about this is we can do much more complex problems like this. What if it wasn't 5 times 16? What if it was 25 times 16? Okay, now I'm not going to actually make 25 times 16 here, but I could make a quick sketch, okay? And maybe I really like that 10 and 6 division. It doesn't really matter where it goes now, because I'm using this tool not as an actual way to count the boxes, but as a framework for doing harder problems. But this time, I'm not just going to divide up the 16 into 10 and 6. Maybe I need to divide up the 25 also. So I'm going to divide it up into 20 and 5. And then now I have 4 boxes I have to find. I have to find the area of. First, I have 20 times 10 is 200. And then I have to find the area of this box. 20 times 6 is going to be 120. Okay, then I have 10 times 5 to make the area of this box is going to be 50. And in this box here, I have 5 times 6, which is 30. Now to find the total area, I would add up all those parts, just like I did up here with those 2 boxes. I'm going to add up all 4 parts here, but these are numbers that I don't need a calculator to add those up. 200 plus 120 is 320, plus 50 is 370, plus 30 is going to be 400. Okay, so I can use these this area model to split this up and find more difficult multiplication problems. Now, I know a lot of people are like, well, why do I need to do that if I could just use a calculator? Well, what if I can't use a calculator? What if I have something that I can't put in a calculator? Like, what if instead of having 5 times 16, instead of having that, what if I have 5 times 2x? Okay, so I could have my 5, but then I don't know how long to make this. But I could have 2x at the top. Okay, and so if you print out your algebra tiles, you can actually do this using an area model, and I'll show you how. I can have 5 ones here, so this is 1, 2, 3, 4, 5 for your algebra tiles. And then you'll have for this part, and then on the top you'll have an x and an x. And so then one time, this is going to make 1x when I multiply, 1x, 1x, 1x. And actually, I'm going to use a different color for these so that you can see that this is my quantity here. And then I can say, how many x's do I have? I have 10 x's. Okay, so here I have my 5 and my 2x. I know that 5 and 2 is 10 times x. So I have 5 times 2x. Again, I can't do that in a calculator, but I can still use my area model. Okay, so if I go back to my 5 times 16 problem, do you see how I could divide it up into any combination as long as it added up to 16? So what I really did here, look at what I did. What I really did here was I said, instead of 5 times 16, I actually did 5 times 8 plus 8. And I actually multiplied 5 times 8 to make 40, and 5 times 8 again to make 40, and that gave me 80. In the second problem, I actually did 5, and instead of times 16, I did 10 plus 6. You agreed with me that 10 plus 6 was the same as 16, and so we multiplied them here. We got 50 and 30, but what did I do? I multiplied this first one together to make 50, and this second one together to make 30, and that made 80. And then the third one I actually did 5 times 4 plus 12. And I multiplied 5 times 4 here to get 20. And 5 times 12 here to get 60. But when I added them, I still got 80. So I could add them in I could split that up as long as it made 16. Now, I actually did the same thing down here. I actually did a really hard distributive property problem, but it didn't seem hard, did it? Because we made it an area model problem. What I actually did here is I split up that 25 into 20 plus 5. And then I split up the 16 as 10 plus 6. So what did I do first? Remember, I did 20 times 10. So I multiplied 20 times 10 to get 200. Then what did I do? I did 20 times 6. and I got this 120. So 20 in my algebra here, okay, there's no x's, but this is still algebra. What did I do? I multiplied 20 times 6. And that gave me 200. I'm sorry, 120. Then I looked at the 5 and I multiplied 5 times 10. And I got 50. So in my work here, I did 5 times 10 to get 50. And then I did 5 and 6 to make 30. Huh. So what did I just do? I actually did this big distributive property problem, but I did it in an area model. And so when I added all those together, I got 400. Okay, so what I've done here with the squares, I used an easier problem, but then I showed you how when you broke it up, you actually were doing the distributive property. Now, why am I telling you this? I'm telling you this because people who have really good math sense and can do stuff in their heads, they're not in their heads, they're not doing 25 times 16 and doing 6 times 5 is 30, carry the 3, 120, 15, and then 0. They're not doing that in their heads. They're breaking the problem up into easier math problems and adding them together. They're actually using the distributive property in their heads because this is very difficult over here to try to keep straight in your head. I don't know if you're like me and you feel like you have to finish the math problem, but there you go. So you can see that, in fact, this math problem, this algorithm that we are taught is actually the distributive property, okay? It's actually the distributive property, but it's easier to see where the distributive property comes from if you use an area model rather than the algorithm. Now, why is that important? Well, it's important because when we move on to algebra and we really do put in the x's, it's too hard to do that using some algorithm. We have to make a visual. So instead of 5 times 2x, let's move on to 5 times, this is how we write things in algebra, 3x plus 9. Now, remember when I did my times 16, how I divided it up in any place? Think of that like the x, right? I had 4 and 12, but I could have just made that like an x, or 10 and an x, an 8 and an x. I could have thought of those like x's. So now when I make my area model, doesn't matter how long it is. I have the 5 here. Doesn't matter how long it is. But when I put in my line, I can put it anywhere I want, because now I'm using this as a framework, not because I'm actually counting the number of squares inside. I'm not, but I'm using it as a framework because I understood how it worked with integers only before I started using algebra. That now I can use algebra. Now I can use the same framework to do algebra. So on the top here, instead of putting like one big thing, 3x plus 9, I'm going to split it up. I'm going to say this first part is sum 3x. I don't really know the distance there. It doesn't matter. And then the second part, I'm going to use 9. I'm going to split it up that way. Okay, now this isn't actually 9. All right, it's okay. It doesn't matter that it's exactly that many squares. What matters is I've made this framework. And just like before, how I am going to find the area of the first block and the area of the second block and add them together, that's what I'm doing here. I'm going to take the area of this first block, 5 times 3 is 15 times x, and the area of the second block is 5 times 9, 45. And just like before, it's like I have 2 rooms in my house, and I want to find out the total square feet. I add them together. It's the same thing here. I'm adding them together. So that's 15x plus 45. Now, when we do this with just algebra without the picture, what do? We say multiply these first two, multiply these second two. Okay, and we get that, right? We get 15x plus 45. But why? The reason is back when we did just regular numbers. Okay, this works for anything. So what if I make it like really hard, right? What if I make this a way harder problem? What if it's x plus 2 times 4x plus 5? Okay, well, okay, let's think back. What kind of problem is that like? That's like this one down here with the 25 and the 16. See how I broke both of them up? Right? I broke it up into 20 and 5 and 10 and 6. So that's what I'm going to do here. When I draw my area model, I could do this algebraically. And eventually we will. We won't draw an area model forever. But especially when you're first starting, draw an area model. Along the side, I have an x's, and then I have 2. An x plus 2. I'm even going to make this 5 over here. Here's the 5, and here's the 4x. Now, if you have algebra tiles, what you do is you actually put the algebra tiles there and then count them. Okay, like we did up here in the purple. So hopefully you'll print those off and you can practice using the algebra tiles. But when you have here, we're going to remember that in front of this x, there's really a 1. There's always a 1, an imaginary 1 in front of the x. That coefficient is always 1. I can multiply 1 times 4 is 4. And x times x is x squared. Now, don't let that freak you out. What does x squared mean? That just means that I have some distance, where do I want to put this? Some distance x times some distance x, and look, when I multiplied them, they made a square. They made a square, and we know that what is a square? What does the area represent? The area represents how many squares live inside. So when we say x squared, we're saying I don't know how many squares live inside, but I know that they're all squares. That's what the x means, right? That we don't know it. But they're all squares. That's why we use an x squared. All right, then in this box over here, I have 1 times 5 is 5x. And in this box down here, I have 2 times 4 is 8, and then times that x. And then in this box right here, I have 2 and 5. That makes 10. So if I want to find the area of this whole box now, what do? I add them together just like I did back here with my 25 and my 16. I added all the parts together. Well, that's what we're doing here. Sorry. That's what we're doing here with the algebra. It's okay that it's algebra. Don't let the algebra scare you. Okay? It's 4x squared plus that 5x we found plus the 8x we found plus the 10. Now, if you did this in your algebra book, they probably wouldn't show you all this. They would probably just tell you to use the distributive property. But what are they really doing? They're going to put a 1 right here. And then they're going to do x times 4x to make 4x squared. X times 5 to make 5x. 2 times 4 to make 8, and then times the x, and then 2 times 5 to make 10. So whether you do it in an area model or whether you do it using algebra and the distributive property, it's really the same thing. The distributive property is just a way to make an area model. Finally, we need to recognize that in this case, we do have some like terms, some things we can add together. We can't add this x squared to the x, and if you have your algebra tiles, you'll understand why. because your algebra tiles will show you that you have this x squared and you have this x. Those are not the same kinds of things. I can't add them together because they're not the same kinds of things. I can only add things that are the same. So 5x and 8x, those are the same kinds of things. They're both these longs here. Okay, so those are going to make 13x, and I encourage you to use your algebra tiles to help model that. And then you have your 4x squared that you'll add to that, and your 10 that you'll add to that. All right, that is a super fast kind of instruction on how to use an area model to distribute, but I do hope that it's helpful.